Alright, so this is continuing looking at conditional probabilities in 7.5. So this is page 3 of the notes. And these examples of conditional probabilities are looking at groups. Right? The first example is going to be a marble example, and the second example is going to be a committee type. So using combinations, counting technique, along with conditional probability types. So this is the type of question that you need to be aware of that now can be asked. And you need to ask yourself, is it a basic case where I'm pulling out of all of my outcomes, or is it a conditional case that I put a condition out of it? Am I already in a set, in an event, and within that event, do I want to know the probability something else will occur? So a bag of candy contains 2 lemons, 3 cherries, 1 grape, 1 orange. You reach in and grab a handful. So again, at this point, it should be second nature that this is a combinations. You're going to pick 3 total, so I have to make sure I have 3 total in my handful. Alright, now the important part that you have to make, again, reading these problems in Chapter 7, being careful with the wording is going to be a very important skill that you need to make sure you pick up. The more you practice, the better you'll get at it. So again, these just come with practice. Alright, so you reach in and grab a handful of 3. You see one of them is an orange candy. What is the probability the other 2 are lemon candies? And so this one's a little more obvious. It's a conditional probability. Right. You know that you have an orange candy, and you want to know, well, what's the probability the rest of your hand is lemon? So you've got 1 orange and then 2 lemons. And so this is the condition, right? The given part is that you know you have an orange candy. Right? That's given to you. You know that. Your handful is not all possible handfuls anymore. It's only the handfuls that I know contain an orange candy, which not all handfuls contain an orange candy. Alright, so this is a conditional. Alright, it's the probability that I get 2. So I'm looking for the chance the other 2 are lemons. So the probability that I get 2 lemons in my handful, given we picked an orange. The only orange, right? There's just 1. So the conditional probability formula is we divide by the given. So the bottom statement is all the groups with an orange candy. Up top is the group with an orange, so 1 orange, and the rest of the handfuls filled by lemons. The probability I picked the orange candy and the other 2 are lemons. So I'll get 1 orange and 2 lemons. All right, so that's the condition. The difference is it's not all groups in my universal set. It's a condition. It's only the groups from the universal set. So I've narrowed it down to only the groups from the universal set that contains the orange candy. Right? And so that's the condition. Right? We're in a condition that we have an orange. And then I fill it out as I do before. So my conditional group, well, I pick the orange candy. Well, there's only 1 orange candy to pick from. Right? So I choose 1 orange candy out of 1. And then this is all groups with the orange, so that means I've got an orange candy, so I've got 1 orange, and then I still need 2 others. All right, and these others can be anything, right? They're any of the other colors besides the 1 orange that I picked. So I've got to pick 2 of the other types. All right, they could be any of the other types. So they could be they could be lemon, cherry, or grape. So I add up how many others do I have? So I've got 9, 10, 11. So I've got 11 others I could choose from. And this bottom event would be all possible groups with the orange candy. Right? That's the condition. That's the given group. Up top is out of all of those groups with the orange candy, how many of them contain both lemons? All right, so up top I'm going to pick my 1 orange candy again. All right, that's the same. And then I also want the 2 lemon candies. So it's a combination. I'm going to select 2 lemons out of 2. Well, there's only one way to select all of them. So if you do combination 1, choose 1, there's just one way to do that. Combination 2, choose 2, there's just one way to do that. So up top is just 1. Combination 1, choose 1 is 1. combination 11 choose 2. I gotta plug that into my calculator. 11 choose 2 is 55. Alright, and so what this means is there are 55 groups that have the 55 handfuls of 3 from this particular bag that will contain the orange candy. One of those 55 handfuls with the orange candy also has 2 lemons, the 2 lemon candies. And then we find the decimal approximation, which is 1818 repeating. Alright, and there's the chance that that happens. Alright, next example. Alright, so it's committee type. So again, as soon as you see the word committee, combinations, right? You should know it's a combination. So we want to pick 3 people. So again, it's a combinations, pick 3. So we've got 3 women, Ann, Carol, and Deb. 4 men, Bob, Ed, Fred, and Greg. Alright, so I've got 7 people total that I'm going to pick 3 from. And so the first question is the probability of selecting a group of all men for my committee. Alright, probability of selecting all men. And so there's no condition on that. That's a basic probability. What is the probability I select all men? There's no condition placed on it, so it's a basic probability. We want to know what's that probability out of all possible outcomes. So it's the probability we get a group of 3 men. So we select all men. So it's the number of ways to get 3 men in our group. Over the universal set. Right, which would be anybody could be picked, right? It's a group of anybody that can be a group of 3 where I'm selecting from anyone. So it means men, women, doesn't matter, I'm selecting from everybody, right? That's the universal set. Right, so fill this out as combination. So the universal set is I can select 3 from anyone. So combination, I can pick 3 of any of the people, whether they be men or women. So combination, out of all 7 people, I'm going to select 3, and that would be all possible groups, all possible committees. Up top is the event. Right? How many of those committees are all men? Right? Contain all 3 people on the committee are men. And so up top, I'm going to select 3, but I'm selecting them only from Bob, Ed, Fred, and Greg. So those 4. So it's combination. I'm going to choose 3 of the 4 men to form my committee. And then you plug those out on the calculator. And so when you plug in combination 7 choose 3 is 35. So there would be 35 different committees. 4 of the 35 contain all men, right? So 4 of my 35. And then you divide it out and find the probability. All right, so 4 divided by 35 comes out to be 1143. And again, what this means is 35 total groups. That's the universal set. It's the any group. Out of the 35, 4 of them are groups with just men in them, right? Contain only the men. Right? That's a basic probability. Right, part B, find the probability of selecting all men given Ed has been selected. And so this one's one where the conditional part is a little more straightforward. They use the word given. As soon as you see the word given, more often than not, it's a conditional probability. So what's been done is we've picked Ed. So Ed is on our committee. All right. So instead of looking at all groups, like the first problem, we've picked Ed. So now we've made a selection, and so now we want all groups that contain Ed, right? That's what I'm selecting at. If I have all groups with Ed in them, what's the what's the chance that that group will contain all men as well? All right, so this is a conditional. All right, so I'm still looking for the probability we get all men in our group. Oops. Given we've already picked Ed, right, which is one of our men. The odds should go up, right? If I already picked a man, the odds of picking a group with all men should go up, and it does. We'll see that it does. Alright, so in words, up top, or we'll start in the bottom. This would be, again, the condition, right? What do I know? I've picked Ed. And so these would be all our groups with Ed. Right? All of them. They can contain Ed with men or women. Alright, all of them. All groups with... Now, again, it's a subset because some groups contain Ed, some groups didn't contain Ed. But we're looking at the subgroup of all of the groups where we've picked Ed, where Ed has been selected for my committee. Up top then is, well, what are the odds if I've picked Ed? I get an all men group. So we want all men given we've picked Ed. Alright, so it's all men and Ed has been picked. Alright, so I'm going to start with picking Ed first, right? Combination, I'm going to select Ed. Well, there's only one Ed, so it's combination 1, choose 1. And that's the same in both the numerator and the denominator, right? I have that choice has been made. I've selected Ed in my division event and in my numerator where I've picked Ed and got a group of all men. The difference is, in the bottom, it's all groups with Ed, which means once I've picked Ed, I need to pick 2 others, and they can be any of the others as long as they're not Ed. So it's combination, I have to select 2 of the other people. Well, there would be 6 people left, right? Because I've already picked Ed. That means 3 men were left, and the 3 women could be chosen to be a part of the event where I've selected Ed, right, in my group. So that 6 choose 2 is finishing out all of my groups that contain Ed. Out of all of the groups that contain Ed, what's the chance that I pick a group that contains all men with Ed? So the top part now is I've picked Ed, and that's what this combination 1 choose 1 is. And then I finish it off. Well, now I want to finish it off with 2 more that are men, right? So my event is getting Ed with 2 more men. So it's combination, I'm picking 2 more, and they're men that can't be Ed, right? So I've only got Bob, Fred, and Greg to select from to finish out my group of all men. So that's 3 people I have to choose to fill out my group with Ed that also contains all men, right? And that's the event I'm looking at. So what it really has done is I've thrown Ed out of the problem, right? I've picked him already, so what I've got left is I've got a group of 2 left over. When I pick that group of 2 left over, what are the odds that I pick 2 men out of all possible picks? Right, that's what this is. Right, well, combination 1 choose 1 is just 1. Right, so combination 6 choose 2 is 15. Combination 3 choose 2 is 5. And so remember, from our previous problem, there were 35 total committees. This means these are the 15 of the 35 that contain Ed, meaning the rest of them are groups, so 20 groups out there that don't contain Ed. Out of the groups of 15 with Ed in them, 5 of them are groups that have Ed with all men. Right, so 5 out of 15, and then you find the decimal approximation, or sorry, let's put 5, I couldn't read my computer, that should be 3, sorry, combination 3 choose 2 is 3, not 5, so make sure you make that correction. That should be a 3, I couldn't read my 5 very well when I had typed that out of my calculator. Alright, so this should be a 3, not a 5. Alright, so there are 3 groups out of the 15 with Ed in them that contain all men. So 15 is all men, 3 of them are, so 15 are the ones with Ed, 3 of the 15 are Ed with all men. Alright, then we find our decimal approximation to that. So I gotta type it in, which comes out to be 20% chance. Alright, so do make sure you change that to 3, not 5. So 3 out of 15, which comes out to 20%. Alright, problem C. Find the probability of selecting all men given Carol has been selected. So again, there's the given. We put a condition on it. We've already picked Carol. Alright, so it's a lot like the last example, except this one's a little easier. We want a group of all men. Given we've picked Carol, who is a woman, right? Carol is up here and she's in the women. Well, it's the number of ways to get all men and Carol would be divided by the number of ways to get all groups with Carol. Now, this one you shouldn't have to type it out. Right? You should be able to just figure out what it is without having to plug it in. But if you did plug it in the calculator, it'd be combinations, all men with Carol. Alright, now this is where we run into where you have to sort of kind of logic this one through. is there any way, if I've picked Carol, who is a woman, to get a group of all men? Alright, the answer to that is no. That is 0. There's 0% chance. This would be some number. There are groups with just Carol, and actually there'd be 15. There'd be 15 groups with Carol in it. But 0 of those 15 are all male groups because Carol is a woman. Right? These are mutually exclusive events. It's impossible to pick a woman and get a group of all men, right? Because once I've picked Carol, it shatters the chance of getting, so it's impossible. I cannot get a group of all men if I've selected Carol. 0 of the 15 groups with Carol in it are a group of all men, right? Because there's one woman guaranteed to be in that group. Right? And so the probability of that occurring is 0. Right? Which again, 0 is a perfectly fine probability. Just means it's impossible. Right? That cannot happen. Now, on your own, find the probability of selecting a group of all women given. So this is the one where you can solve it. So this is a lot like part B. So to try this on your own, this is a conditional. It's the condition where I've got Carol. Right, I want to know the odds of then selecting a group of all women if I've picked Carol. And again, I'll post the answer to that later on. Alright, so I'm going to stop the video here. So this is sort of the last of the conditional, just going through and practicing conditional probabilities. So this was a conditional probabilities with combinations, groups and our marbles. The next set of notes is going to look at conditional probabilities specifically if we're given an application type. Within the application, usually given as a percentage, we don't have to find conditional we might have to find some conditional probabilities, but within the problem itself, we're given conditional probabilities, and these are going to be applications with conditionals where we'll solve them with trees. So if you remember last time I said we'll solve applications with trees, this is where we're going to get to in the next set of notes from 7.5. And usually tree applications aren't too bad. Students, once they practice it, they kind of get the hang of it and they're not too bad, but that's where we're going in the next set of notes. Alright, so we'll stop there.